Hello everyone, it's Miss Elizondo here again. Please grab a pencil, your notes, and let's go ahead and get started today. So today again we are going to review the laws of exponents. This is on the notes under February 9th. We are going to look at two new laws today. It's the product law, which means multiply, and the quotient law, which means to divide. And we will be going in further detail on the product and the quotient law, so let's get started. Okay, so now today we are going to focus on making sure that when you simplify, you have the same base does not appear more than once. If it is there more than once, then we need to do some simplifying using these laws of exponents. So looking at our first rule, this is the product law, which means to multiply. So when you are multiplying and you see that you have the same base, just like this example here, you are going to add the exponents. So you keep the base, you only write the base one time, and you add the exponents. So I like to call the exponents the little kids. Think about little kids. Like in kindergarten, they do not know how to multiply yet, so they are going to add. So for example here, we have this expression, a to the 6th times a to the 5th times a. If you write it all out, this is what it means right here. There are 6 a's, 5 a's, and 1 a, and all together that is 12 a's. Instead of writing it all out like that, you can just write a to the 6 plus 5, and then there's a 1 there, so plus 1, and it still totals up to 12, so you still end up with the same answer. Now let's go ahead and look at a couple of examples with the product law. So we have the same base here. The 12 is considered a base since there is an exponent attached to it. So we keep the base, we only write the base once, and then you add your exponent since we have multiplying here. So 4 plus 3, which is 7. So that means we have 12 to the 7th power. Now we have negative c in parentheses, and that is our base, and we have the same base, so write your base down once and add your exponent. So negative 2 plus 7 is 5, positive 5. So we have negative c raised to the positive 5th power. And last one here, we have t. So same base, so keep your base and add your exponents. 4 plus negative 2 is positive 2. So therefore, we have t raised to the 2nd power. Again, that is the product law. Go ahead and take a look at the quotient law. So when you are using division, or when you see division, when you divide expressions with exponents, you must subtract the exponents with the like bases. So now, let's talk about the little kids again. We're going to say they cannot divide yet, so we're going to have them subtract, okay? So you see this example down here, m to the 6th divided by m to the 3rd power. They have the same base, so we're going to subtract 6 minus the 3, which leaves us with 3 exponents left over of m, so m to the 3rd power. Now, the way that I like to set it up, you're still going to get the same answer, but I feel like this takes a lot of the guessing of where my variable is going to go. So I always ask myself, okay, which exponent is the smallest? I'm going to subtract the smallest from both of them. So since 3 is smaller, I'm subtracting 3 from both. And we learned yesterday that 3 minus 3 is equal to 0. Well, anything to the 0 power is, you guessed it, it is equal to 1, so it can cancel out because we're just left with 1 there. And 6 minus 3 is 3, so we're left with m to the 3rd power, which is what they were left with down there. Okay, now I like the way that I do it for this example here. Notice that we have 5 minus 8, but 5 minus 8 is a negative, so then you need to recall the negative rule and turn that negative into a positive by moving it downstairs to the denominator. Now, if you follow my way and we subtract 5 from both, well, 5 minus 5, that's 0. Anything to the 0 power goes to 1. And then 8 minus 5 is 3, so a to the third power down here, and we do not have to do any switching around. It's already set up correctly. Okay, let's go ahead and practice a little bit more. So here we have r to the third divided by r to the seventh. Same base, so let's subtract the smaller one. So minus 3 minus 3. 3 minus 3 is 0. R to the 0 power is 1 over 7 minus 3 is 4. So we're left with r to the fourth power in the denominator. Now let's look at b. 3 is the smaller number, so subtract 3 from both. 3 minus 3 goes to 0, which is x to the 0 power equals 1. So we have 1 in the denominator. 8 minus 3 is 5, so we're left with x to the fifth, and then there is no more need for a fraction since we only have a numerator. Now let's look at c. Notice how c has a base of 3. Even though it is a number, it is still a base, so don't think about it as a coefficient since it has an exponent. So the smaller exponent is 5, so let's subtract 5 from both. 5 minus 5 is 0. 3 to the 0 power is 1. So our denominator goes to 1. 9 minus 5 is 4, and 3 to the fourth power. That's what we get. So your answer could either be left like this, 3 to the fourth power, or 3 to the fourth power means 3 times 3 times 3 times 3. And when you multiply all those 3's together, you come out with 81. So you can either see your answer as 3 to the fourth or just 81. It might show up as an answer choice either way. Okay, last one. So looking at D, our exponents, again, we have the same base, but our exponents, one is negative and one is positive. So our smaller exponent is the negative exponent, the one that's more negative. So negative 4 is the smaller one, but in order to cancel out negative 4, I cannot subtract negative 4. That's going to give me negative 8. So what I have to do is add 4 so that it can go to 0 and go to 1. So that means I'm going to add 4 to the top, to the numerator. So j to the 11th power, and we're left with j to the 11th power in simplified form. So that is the quotient law, guys. Thank you for joining me today. Please make sure to complete the next 4 problems on your Schoology assignment, and you have a great day.